In this video, I'm going to show you how to create a blockchain game step by step. And we're going to use one of the hottest blockchain protocols out there, Chainlink. And this is the perfect time to do this because Chainlink is getting a ton of adoption in the crypto space. And this is a really important technology for you to understand if you're going to become a blockchain developer. But don't worry if you don't understand like what Chainlink is or how blockchain works. I'll explain everything in this video. So before we get into that, if you're new around here, hey, I'm Gregory. And on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash the like button down below and subscribe to this channel. And if you want to learn how to code blockchain step by step from start to finish, then head on over to dappuniversity.com/bootcamp to get started today. Let's take a quick look at the application that we're going to build in this tutorial. This is a blockchain-based betting game where you can bet on the outcome of a dice roll with cryptocurrency. And if you guess right, then you double your money. This game is powered by Ethereum smart contracts that run on the blockchain. And we're going to use the Chainlink protocol to implement randomness for our dice roll. Here's a quick diagram of how the application will work. First, the user will connect to their web browser with metamask. They'll talk to a front-end application built in React.js, and then that application will talk directly to the Ethereum blockchain. And on the blockchain, we'll create a smart contract that implements the betting game, and that's going to use the Chainlink protocol, which of course talks to the Chainlink smart contracts. So the user flow here is that they make a bet directly to our smart contracts with the front-end application. And if they guess the number right, they will win twice the amount of cryptocurrency that they bet. Now let's talk about how we're going to use Chainlink in this tutorial. So really quickly, Chainlink is an external data provider for the blockchain. So it's an Oracle service, which means that it provides real-world data to smart contracts. So one really common use case for Chainlink is to provide cryptocurrency prices to smart contracts, like exchanges, for example. But it is a lot more than that. And specifically, what we're going to focus on today is Chainlink's ability to provide randomness to smart contracts, which is an essential feature for gaming. There are some inherent issues with generating random numbers in Solidity, and I'll provide a link to this article down in the description below because I think it does a pretty good job of explaining why. So if you want a pretty in-depth explanation of that, make sure you check this out. But Chainlink actually provides random numbers to smart contracts. And that's exactly what we'll use in this tutorial. We'll use Chainlink's contract specification for providing random numbers. And that will help generate randomness for our betting game. So you can see how that will work in today's tutorial, and you can apply this method to create any game that you want to that requires randomness. Now let's go ahead and install the dependencies we need to build the project. First, you need Node.js. So you can see if you have Node already installed by going to your terminal and typing node-v like this. And if you don't have Node already installed, you can install it directly from the Node.js website, or you can always use a package manager to install it directly from your terminal. Next, we need to turn our web browser into a blockchain browser so that we can use the betting game. So we'll do this with the MetaMask Chrome extension. So just Google MetaMask for Google Chrome, go to the Google Chrome Web Store, and click install right here. And whenever you do, you should see the Fox icon up in the top right-hand corner of your screen. Now let's go ahead and download the code for the project. So I'll put a link to this repository down in the description below. This is just the GitHub repo for the final code solution. So I'm just going to copy this from my web browser. All right, go to my terminal and say git clone, and then paste in the repository URL here. All right. And now that's finished, I'm going to enter into that newly created directory like this, say cd Chainlink betting game. All right. And now I'm going to install all the dependencies for the project with npm like this, npm install. And once all your Node dependencies are installed, go ahead and open up a project in your text editor of choice. I'm going to use Sublime Text for this tutorial. So let's go ahead and take a tour of the project here. So all the code's going to be inside the source directory. So we can see the contract directory for the smart contracts that we'll put on the Ethereum blockchain. So bettinggame.sol is going to be the main smart contract that we're going to use for this tutorial. So you can see all the code inside of here. The main logic for all the code is going to be the game, which we'll talk about here in a minute. All right. And this, of course, uses the Chainlink smart contracts for doing verified randomness. So we'll take a tour of the code here momentarily, but let's go ahead and continue looking at the rest of the code of the project just from a high level. Then we'll put this smart contract on the blockchain and we'll explain how it works. So next, go to the components directory, and this is where the application code written in React.js will live. All right. So this is our main component, the app component. There are also a few more components, one for the nav bar and also the main content of the page. All right. So we'll go over all this when we set the application up. But let's move on. Now let's go ahead and put this smart contract in the blockchain. So head on over to remix.ethereum.org. So we're going to put the Solidity source code inside of this online code editor and put it on the blockchain so that we can use it in our application. All right. So I'm just going to take the code here, copy it, and then paste it here inside of Remix. All right. And what we're going to do is compile it first. All right. So click compile right here. And then we're going to choose 0.6.6 because we're using Solidity version. That's the Solidity version that we're using for this particular tutorial. So we can compile it, make sure everything works properly. All right. And so next we want to deploy it and put it on the blockchain. So we're going to use a test network for this. All right. In fact, we're going to use the Rinkeby test network. So in order to do that, we must pay a gas fee to put this smart contract in the blockchain, and we need some test cryptocurrency in order to do that. So, I'm going to put a link to this in the description below. This is the Rinkeby faucet. You can simply request Ether from this faucet by creating a social media post. Just follow these instructions here. You basically make a tweet that will just say that you are, requesting funds to the Rinkeby, that you're requesting faucet funds from the Rinkeby test network. And then you'll just paste in your address here. And whenever that's done, you'll copy the link to the tweet and then paste it back into this address here. Say, give me Ether. I'm going to do 18.75. And once that's finished, your wallet will be funded. Next, we also need to get some Chainlink tokens in order to use the Chainlink smart contracts. So we'll paste in our smart contract address here, verify that we're not a robot, and then get 100 test link tokens. Now that that's finished, we can go ahead and put the smart contract on the blockchain. All right. So, we'll go to the deployment step here. All right. And if you don't have this, just make sure you go to the plugins, this little, plug right here, and just search for the deployment plugin. And so what we're going to do is select the injected Web3 provider right here. Okay. So in MetaMask, you want to make sure that you're connected to the Rinkeby test network here. All right. And that you have, some Rinkeby test Ether. And you can also go ahead and add your link address like this. Just click copy and then go to MetaMask, click add token. And then we'll do custom token, paste in the token contract address here, click next. All right, and there we go. You have 100 link. So now that you're verified that you are connected to Rinkeby and have some Ether for the deployment, let's go ahead and select the betting game. All right, and then click deploy. And then sign the transaction in MetaMask. Click confirm. All right, it worked. And so we can see the smart contract here. All right, so here's all the functions, and we'll do a quick demo of how the smart contract works directly into our browser before we connect it to the front-end application. But now let's just take a quick overview of how the code works so that we can explain these functions here. So now let's look at how the smart contract works. So first and foremost, this implements, the Chainlink random number generator. So I'll just show you that in their documentation. So they have an example here. Again, there's a link down in the description below for this on how you can, get a random number with Chainlink. All right. And so basically, here's the smart contract starter code for doing that. They basically suggest how you do it. You create a contract called random number consumer that inherits from their own smart contract. And they have some setup code here that are some requirements that you must put in your own smart contract in order for it to work. So basically, your smart contract needs to have a key hash, a fee, random result, all right, and then a few special functions, one like get random number, okay, and then one that does fulfill random request, and this is a specific callback that's fulfilled from the Chainlink smart contract itself. And that will, track the random result for your own smart contract. So I have an example of this in the GitHub repository as well. If you look at the contracts and go to betting game start, okay, you can see that boilerplate set up here, and you can use this as a starting point for your own smart contracts if you'd like to. But that's what we did here. So basically, first and foremost, we've inherited from the Chainlink random number smart contract here. We've imported it at the top of the file directly from GitHub. Okay, so it tracks the fee, the random result that's provided by Chainlink, the verification smart contract address on the Rinkeby test network. That's really important to know. Also the link address on the test network as well. And you'll see some of the other functions like the get random number function here, the fulfill randomness function. And then we've coded some extra functions in here to actually build the game. And I'll talk about that right now. So let's look at the main game function now. So what it does, let's look at our chart. So basically the user makes a bet directly to our smart contract by calling the game function. And what they do is they bet on a dice roll. And so they bet the low value or the high value, which is going to be either 1 through 3 or 3 through 6, right? And they'll provide a random seed for that number, all right? And then if if they win, then they win twice the amount of cryptocurrency that they had. And if not, then they, of course, they lose the bet. And so we can, go ahead and test the game function out. But before we do that, we actually need to send some Ethereum cryptocurrency to the smart contract. All right. And also some Link tokens. Because remember, we need to pay the fees with Link and then in order to use the service. And then we also need to have some, cryptocurrency in the smart contract to pay the users out if they win cryptocurrency from the bets. Okay. So I'm going to copy the smart contract address here. All right. I'm going to my MetaMask account. I'm going to send it some Ether. All right. Paste it in. I'm going to send it, 2 ETH. Okay. Click next and click confirm. So I've already done this step actually off screen, so I'm going to reject it for now, but you need to do this and wait for it to finish so that the smart contract has Ether, all right? But the next thing we want to do is also send it some Link tokens. So let's look at the assets, go to Link, which you added earlier, click send, paste in the smart contract address, and I'm just going to send it, like 20 Link for now. Okay, click next, and then click confirm, and then wait for that to finish. Whenever it's finished, you can also verify that your smart contract has the funds on rinkeby.etherscan.io. Just paste in your smart contract address here, and you'll see that mine has 2 Ether now, and that it has 20 Link tokens. All right, so now let's do the game function. So basically, we're going to place a bet, either 1 or 0. I'm going to do 0. And 0 stands for basically values 1 through 3 on a dice. All right, so 0 is low, 1 through 3. 1 is high, so 4 through 6. And then I'm going to put in the random seed. So this is what's used to generate the random seed in the Chainlink verification. So basically, you see this get random number function that's implemented by the Chainlink smart contract right here. And this is what requests it from the Chainlink smart contract that we've implemented. All right. So basically, I'm going to generate the seed like this. I'm just going to say 5, 6, 7, 8, 9, just some number, right? Click transact. And of course, I got an error here because I forgot to send in my bet. All right. I got to send in some cryptocurrency for the bet. Okay. So we do that in Remix like this, do MSG value. All right. So this is for sending cryptocurrency in with the transaction. I'm just going to do 1 way for now, or yeah, just way. This is the smallest value of Ether you can possibly send. I'll just do it for test purposes. Click transact. And click confirm, wait for that to finish. And then whenever the transaction is finished, you can see the successful transaction confirmation here on Etherscan. You can see that the function was called and that the fee was paid to the Chainlink smart contract for providing that random number to our smart contract, okay? So let's go through the logic here so you can understand how this works. I'll bump it up a little more. So again, the game function is the main function for the entire thing. So you pass in your bet. Basically, is it low? So 0 is going to be 1 through 3 on the die. 4 through 6 is high. You'll pass in the seed that's used to generate the random number. This could be any seed that you want to help verify the randomness. And then we have some basic requirements in Solidity that this has to be a 0 or a 1, and that the cryptocurrency sent in has to be more than 0. So don't forget, you send in cryptocurrency as your bet, all right? And then basically we have a unique ID for each game. All right. And then whenever you call this game function, we increment that ID and we use this game struct here. All right. That basically has the ID of the game, the bet, the seed, the amount, and the player. So basically all the data that that's sent in anytime this function is stored inside of a game struct inside this games array. Okay. And so finally at the end, we do get random number. All right. This is the function that's, implemented, that calls the Chainlink smart contract. So it makes sure it has, Chainlink tokens. And then it requests the random number. All right. And then, it talks to the Chainlink smart contract, which does its magic. And then it calls back to our smart contract with this special function that we've implemented, fulfill randomness. And it provides the random result. Okay. And then we add this extra code here for the verdict. All right. That we've customized down here. And we pass the random number that comes back from Chainlink into this verdict function. And basically this just settles like, did we win the bet? Basically take the game and we reset it. All right. So we say the win amount from the game is 0. And then basically, if the user wins, then they get twice the cryptocurrency they bet. So if you bet 1 Ether and you were right, you get back 2 Ether. All right, so you double your money. And if you lose, of course, you don't get anything. So you can say, basically, if you've won, then we multiply your amount by 2. All right. And then we take your address from the game, and then we call transfer, which is the function inside Solidity that sends cryptocurrency to this user, and we basically send you this win amount, like I said, which is twice the Ether amount. Okay, so that's the basic logic of the game. And then we have a few extra functions, of course, like withdraw link, so you can take all your link tokens out of the smart contract, and also withdraw Ether, so you can take any Ethereum cryptocurrency or Ether out of this smart contract as well. And you can see a few other things like fee and the admin are also set inside the constructor function. This is the function that's called whenever the smart contract is deployed to the blockchain. And we just set those values to some intelligent defaults, like the person who deployed the smart contract is the admin or the owner, and then the fee is just going to be 0.1 link. All right. Now let's go ahead and do the front end part of the application. All right. So go into your code editor and go to app.js. Okay. And let's update the smart contract address. So this should be your specific smart contract that you created. All right. So, go back into Remix. Let's see here. Let's just copy this. Kind of gets hidden on the page here. Then paste it in. All right. That's your updated smart contract. So now let's try to run the app. Let's go to our terminal, say npm run start. This will run the web server. All right. All right. And once that's done, you can see the application loaded in your browser here. This should automatically pop up. You can see the account that you're connected with here in the top right-hand corner. Of course, you can see the betting game application here. And then here it is. Here's our little dice animation, and we can play the game like this. All right. Well, first, let's say we've got the max bet, all right, which is 2 ETH. All right. So that's the exact amount of Ethereum cryptocurrency or Ether that we sent to the smart contract when we set it up. Okay. And then the balance here is your current wallet balance of your account here connected to MetaMask. Okay. So the max we can bet is 2 Ether. And yeah, this is how much we're allowed to bet. So let's just bet, let's say 0.5 ETH. Okay. And then let's just bet low and let's play. All right. Click confirm. And womp womp, we lose. Okay. So you can see that alert pop up here. So you lost, and your balance, of course, went down. And, you can't bet anymore, for that particular one. So you can see it refresh here. Once we, click accept, you can see the max bet is now 2.5 Ether because we lost and sent the, cryptocurrency to the smart contract. And, here's our wallet balance gone down. So you can play around with this, try to bet a different amount and, keep playing until you win. But let's take a quick tour of the front-end code to see how it works so that you can, customize this yourself, build your own application that implements this type of logic. So the main part of this application is here in app.js. This is the entry point. So this is, written in React.js, which is a framework for building user interfaces. And so this is a React component, here the app component, all right? So it uses the Web3 library to connect the application to the blockchain. So if MetaMask is our, wallet that turns our web browser into a blockchain browser, then Web3.js is the library that turns our application into a blockchain application. All right. So we connect to the blockchain with Web3 like this inside this load Web3 function. Okay. Which is called here inside the component will mount function. This is just a lifecycle method inside of React. All right. So load Web3. That's the first step. Next is to load the blockchain data. So what this does is it connects to our specific network. Here we're, specifically connecting to the Rinkeby test network, the network already of 4. And then we load the betting smart contract. So, of course, we pasted in our specific smart contract address here on the Rinkeby test network in the previous step. And so we need 2 pieces of information, the smart contract address and also the ABI, which is just a description of how the smart contract works, the functions and things like that. This is just a JSON object inside of an array, all right, or several JSON objects inside of an array. So with the ABI and the address, we can create a JavaScript version of the smart contract inside of Web3.js like this. So we say the betting smart contract is this, all right? Then we also load the account from MetaMask right here, the account balance, and also the max bet from the smart contract like this, okay? So all this information is stored in the React state, which you can see here. So this is React's state object. It's kind of like a database on the client-side application. It's going to store the account, the amount, the balance, the contract, all that kind of stuff, okay? Let's look at how it works. So the make bet function is the main logic for playing the game, all right? And this has the seed for the randomness hard-coded into it, all right? So you go back to Remix and see that we passed in the seed manually here. Well, the code just hard-codes it inside of here. Okay, generates a new one whenever we call this function. All right, so this is the Web3 way of calling the game function. So we pass in the bet, which is of course user input, and then the random seed, which we've stored here. This calls the function and does the betting, and then we listen to the smart contract events. Okay, and whenever the result event is triggered, we subscribe to that. Whenever it's triggered, basically the verdict is 0, then we lost. And if the verdict is not, then we win. All right. And then we raise an alert to the user whenever that happens, which we just observed a minute ago. Okay. So you can see a lot of that down here rendered onto the page inside the render function. So we have the nav bar, which, shows all this information up here. Okay. You can see the nav bar code here. All right. And then also the main component, which is rendered here, which stores all of the, the main content for it. Okay. And we also have a loader. So if the app's loading, we show this loader here. All right. And then if it's not loading, then we show this main component, which basically has all this stuff. So it's got the GIF of the dancing die. It's got this form for the bet, and then the low and the high buttons. Okay. Here's the form. Okay, right here. And inside of here, we put the amount that we want to bet. Okay, so here's the Ether amount. That's this right here. And then here's the button for low. All right, and then here's the button for high. Okay, and inside of these, we make the bet whenever we click them, and then we calls this function right here, which I explained a minute ago, for make bet. And this is what, calls the smart contract. And when that's finished, if we win, then we surface that, alert to the user. If we lose, we also surface that.